Achoo!
Your body's in a constant battle against bacteria.
Hey!
These creatures come built in with a variety of ways to attack the human body.
Hey!
You can become infected by food, water, touch, or even air, and bacteria is everywhere. A typical bacterium has a cell membrane and a cell wall. Within the bacterium, we have a circular DNA, RNA being synthesized, and ribosomes synthesizing proteins. Up until the early 20th century, lack of disinfecting techniques and poor hygiene practices led to many bacterial infections. During the 14th century, the bubonic plague, a bacterial infection, reduced the population of Europe by about 60% and the world's population by almost 100 million. At that time, bacteria's only predator was the natural immune system, and its evolution focused on combating that.
A lot of the drug-resistant bacteria, including TB and its relatives, are becoming resistant to almost every antibiotics that's being used. Partially, this is due to the evolution of antibiotic resistance through genetic means. Partially, it's due to the transfer of plasmids across different bacteria.
In this experiment, we're going to try and isolate and grow the bacteria and microorganisms that are found in the environment all around us. In front of me I have two petri dishes filled with agar medium, which is a type of jelly-like substance which provides nutrition for bacteria and microorganisms, allowing them to grow at a much faster rate than they normally would. The procedure for this experiment is incredibly simple. All we have to do is get a sterile petri dish full of agar, open it to the air around us, leave it open for an hour or two to allow for contamination to occur. We then close it and incubate it at constant temperature. This particular petri dish was opened in a bathroom and sat there for 2 hours before being closed and kept at 20 degrees Celsius. After a week, we can see that many bacterial growths have occurred on the surface of the agar.
Approximately half the bacteria don't grow, and so in the interim, the doctor basically has to prescribe just antibiotics just in case, without really knowing what they're for or what they're directed against.
Even the presidents weren't safe from bacterial menace. In 1924, 16-year-old Calvin Coolidge, son of President Coolidge, developed a blister on his right foot while playing tennis. Before long, he began to feel ill and ran a fever. Signs of a blood infection started to appear, but within a week, he was dead. Another problem that helps to accelerate this natural process is that people take antibiotics wrong. They either take a low dosage over an extended period of time. Some people don't finish their prescribed dose. But fortunately, some people are smart enough to take the full prescribed dose. This leads to a fast reproduction of bacteria that is immune to our developed antibiotics. This problem can be solved by developing new families of antibiotics. However, a new one hasn't been invented since 1986. If this immunity continues to grow, we could be facing a return to the Dark Ages within the next century.
You better start writing your will. Over to you, Sai. Oh, I smiled. On the recent breakthroughs in antibiotics after... Oh, shut up, Mark. I'm just gonna keep going. No! Why did you do that to me? Has discovered a vaccine for polio. Over to you, Morgan. Not over to you. Over to you, Simon. That's gonna... Was that better, though? Today, groundbreaking news in... Oh, that's too slow. That's too slow.
Some people don't finish. Some people don't finish the recommended course.
Mark!
You make eye contact with me.
Why?
need to leave the room.
Oh my. He continues to increase.
Develop and
Just keep rolling.
Keep go- no, go in.
Yeah, go ahead.
Yeah.
get your shit together, Mark. Thanks, Morgan. Today, after Alexander Fleming's discovery of penicillin in 1928 and the recent breakthroughs in antibiotics over the past couple of decades, Jonas Salk has successfully discovered a vaccine for the crippling polio. Over to you, Salk.